My name is Matthew. I'm going to tell you today how I've fallen in love with the checklists lately. A few words about me. I'm working for a bespoke software company as a sysadmin. Together with my team, we're struggling to keep over 600 users and 300 servers at bay daily. That goes for single VM roles to beasts, do not touch or it will explode. So as most sysadmins, we do work in under time. We don't have time for anything we would like to do at work. So maintenance is not sexy. Documentation is not sexy. And this is part of our job. And because I'm very lazy, I like to automate anything I can so I have more time drinking coffee. Over a year ago, together with my friends, we started a Polish PowerShell user group. These modules that I'm going to present you today are part of our work. We try to open source what we do on our daily basis at work. So, a few questions first, so that I'll know you better. Who doesn't know what Pester is? That's so. Great. Who have used Pester before? Okay. Who knows the term OVF, the Operation Validation Framework? Brilliant. Do you have your environment or services checklisted? Not so good. Do you have it automated then? Those who have. Yay! Okay. This is what I will be talking about today. Automating your checks. To automate, one first must know its service. It must know its internals, know how it works, know what the status green for the service means, what does it mean it's in bad shape. So once you know that, you need to describe your needs. You need to know which parts of and elements of the service you want to test in the first place, to monitor and to be aware only of those components that are important. I think most of you have heard of the term of log noise, when you log everything and then you see nothing underneath. So eventually, when we know the service and when we know what and how to describe that, we can start monitoring the service for the risk elements. We can then go into reporting. It's not far away from there. Today I will show you how using our module, our OVF and OVF Diagnostic, can speed up the process for you based on these services like Active Directory, DHCP, and Software Storage Spaces Direct Cluster. Within seconds, you can create a baseline, a documentation of your service, and then get your tests done in a few more seconds. Okay, for those of you who doesn't know Pester, which there are none, so I'll skip that. I'm not sure if you know, nearly 700,000 it has been downloaded already from the PowerShell gallery as of today. The usage may be a little bit more because it was included in Windows 10 and Windows 2016, unfortunately, because later on it posed a few quirks when you try to upgrade it from the PowerShell gallery with a certificate. You have to skip the check. Anyway, it started the flow. So, as it was, the Pester was designed as a TDD platform. So, first write your tests before you write your functions. And that is something I'm not totally knowledge of. I'm an ops guy, I'm not a developer. So I try to use the Pester for the elements I know, and that is infrastructure. So instead of testing whether my function will properly change the infrastructure, I just change it, and then test it with Pester whether the change was correct. That gives me more credibility, because changing my way, or the automated way, is the way I do. It's the way our team works. But not everyone on our team are PowerShell users. We still have click next admins. We still have support, which tend to go for the GUI. So how then do you report? How then do you check whether the service they deployed are in a consistent way? This is one of the ways. The great power of Pester is it's in community. So not only the modules that the pull requests that are put into the Pester, but also the modules that are built on and around Pester. Also, open source binaries like report unit, which was not built directly for Pester, but because Pester uses an unit XML output file, it can easily consume the output and generate HTML files, which are quite user-friendly for reviewing. There are a number of projects out there who would streamline the OVF implementation. The three of I'm aware and I had the pleasure to work with. The first one is the OVF. This is the default Microsoft operational validation, which is also included like Pester was in Windows 10 and Windows 2016. Oops. This is the module that helps you build your own modules with diagnostics inside and test your infrastructure. It lacks a few features, but it was a great start. Then goes the DBHX, and I'm sure it doesn't have to be introduced, especially not in here. Then goes the Vesta. Who knows what Vesta is? Yay, a few. Okay, so Vesta is Pester combined with PowerCLI to test VMware environment, but only test, but also document and fix it once it checks that it's not a desired state configuration. Okay, what is the story behind our modules then? Why not using the included OVF modules and why we decided to split it into two modules anyway? And why not use DSC? Well, for ops, for us, for admins, change is constant. And by change, I mean any change in our environment. That change can be introduced by a reboot of a server, reboot of a service, or redeployment of a service if there are people who, instead of troubleshooting, just tear down the environment and build it from scratch again, using, for example, DSC. But also a change that is away from us. So you've got your service. The service is being deployed on some services, like some servers, Windows servers, Linux servers, whatsoever. But do you maintain the whole environment, including network, including storage, including power, including connectivity to your services? Till we get the full software-defined stack for everything. And I hope there is a company that has everything already software-defined. If so, let me know, I'll put my CV there. So till then, we need to work with teams that are siloed. So we need to verify that all settings, not only those deployed by us, but also deployed by other teams, are in place so that it will work as it should be. Operational tests are supposed to give us a better understanding, but also a better credibility whether the service will work once we deploy that, once we put our code, whether it's a software, an application, or our PowerShell module that should work in a way we design it to, that it is working the way it should be once it's deployed on a service. Okay, why not use the Microsoft then? Two reasons mainly. First, it lacks features like Windows event log, writing to event logs or writing to files, which can be useful in some situations. Of course, you can build that into every diagnostic module you want to include, for example, DNS or the HCP. But then again, every single module that you will use for diagnostics will have the same features. And the other thing is, it's lagging a little bit behind the official Pester release. So the OVF module from Microsoft, from the GitHub, is not always up to date for the Pester, which introduces a lot of nice features and that can be very rewarding. For example, building a checklists with the because block. Any of you heard of the because block introduced in Pester? Okay, basically this is another feature that if the test fails and if you add a because block, not only it will show the test failed, but also tells you why it should not fail or why the settings should be enabled. A simplest example, the anti-malware should be enabled because it is safe. It's a single statement that is very easy for support for down-level people using our checklists later on. It gives them already an explanation why they should change the settings. Why not use any other DSC-like software like Chef or Puppet? As I said before, not all the environment is already automated. is already augmented into Chef or Puppet. So still, the OVF has its place, has benefits or values you can introduce into your business. So why then we decided to use the OVF and OVF diagnostics built by our own? This is what I want to show you today, and this is what I want to show you what's the value behind those two modules. Okay, the beginning. The first trials with Pester a few years back, this was a new black in town. Like 2 years ago, everybody was talking about Pester, but to find a real-life example besides simple features was a daunting task. So I decided we build our own. In my company, in our company, users do not run with scissors. We stripe the administrative privileges for every user. They don't have local administrative rights on their machines. But because we are a bespoke software company and our developers require to install something or restart services very often, we introduced an additional alternative account for every user. That is called the work admin account, and is being populated for every user that requires that. To have that working in a consistent manner, it has to be properly configured. It has to be added to proper groups. Those groups has to be added to the machines the user has access to. Sometimes there are more than one workstation. For example, I'm using 3, so my work admin should be introduced as a local admin to all those 3 machines. Also, that means that the user having the local admin even on the alternative account won't alternate its primary account, because it will be easy for him to grant back the local administrative rights for the regular account. This is where OVF comes into place. So at first, we had to plan the account. We had to talk with the managers. We had to talk with support teams, with department managers, with quality, with security, and get all the processes, get all the working gears that should be put in place before the account is properly configured. That is the boring stuff. That is walking and talking. Then the coding phase began, so we've decided to use a simple PowerShell object that will contain all the information from the environment. That includes Active Directory, that includes workstations the user has access to, that includes the database that we keep for passwords one time. The user has to change the password, but once the account is deployed, and users tend to forget that support requires to reimbue the password back to them, they could use the SQL database to provide the password one time. So then creating the PowerShell object began, and this was the fun part because it's PowerShell. After that, we prepared the Pester checklists, which worked as a reminder also to support, because it's human readable, it's user friendly, with the it blocks and describe and context all over the place. Even non-technical person that doesn't know PowerShell can read it, even quality or security can read it, and see what are the steps required for the account to be properly configured. So that also worked as a documentation guide for support if the account was not to be created in an automated fashion, so-called exceptions. So once I have the process to gather all the data from, as I said, Active Directory, workstations, groups, any other objects that will hold the information, I'm preparing a JSON file that I can store on a secured workstation. Why? Because I can create the object every hour for every user. Once I have the JSON object in place, I can import it anytime I need and see with a timeline whether the account was tampered with or not. As I said, the user can change, having local administrative rights on his machine. He could alter his machine, saying, okay, I'm granting Bob instead of Adam the access to my machine. So checking Bob account would say he has admin rights not only to his workstations, but also to Adam's workstations. Okay, so I've got the object. What's more? Then I'm passing the object as a param to the Pester tests. So the Pester tests are generalized. They are not for every user. They are just using a hash table of properties to test against. And those tests are really simple. Basically, whether the value in the object is as it is supposed to be. True, false, should be null, or should be equal to something. The tests are done. I have the results. As I said, the output is an unit XML file, so I can use, for example, report unit to create HTML-rich reports, which are kind of interactive. You can dive deep inside. You don't need to read from the console. It's one time if you run it. But if you have it on disk, if you have it in file, if you import it from JSON to the SQL table, you can add Power BI reports. You can see it in time. For now, the HTML is at least human readable, so the security and quality teams, without the PowerShell knowledge, without the PowerShell delegation to run the tests itself, can see the results in time. Okay, after this proof of concept that was running for 5 days. 5 days took creation from the first checklist to running it against 600 user domain. And I had all the reports. What I want to say is writing a PESTA test is like writing a checklist. And writing a checklist is supposed to be in the knowledge of a 7-year-old boy. My son can write a checklist when he's going on vacations, what he needs to bring with himself. It requires a knowledge of him, what toys he has. The same goes for us. We need to know what the toys are in our closet, so what the service is. Once we know that, creating a checklist is really a simple matter. Now, the fun part begins, the coding. So how to code, how to get the details of the service. You can use web requests, you can use native commandlets, you can use whatever you want. Just right now you know what you need to learn. Okay, so the concept after the first initial trials, we sit down and written all the features we'd like our module to fulfill. The first one was to document the environment. So we hate documentation, we hate writing Word documents. We wanted an automated way because anyway I'm getting all the properties from the environment, why not store them? So we have the documentation in place. Now the checklist as PESTA tests. Because of the user friendliness, once you run it, the green-red console states everything's okay, nothing's okay, and the reports we can generate later on. Because we can generate the documentation on the fly and store it somewhere on the disk, we can later compare it to the live status of the service in 1 hour. So we can compare whether the documentation state, the documented state of the service is still the same. Pretty much the same what DSC, Chef or Puppet does when it runs the compliant tests. But again, what I can do, I can query my service from a remote workstation. And that will check whether the network ports or the firewall is configured as it should be. And because the firewall is configured by the network team, I cannot use DSC to configure their firewalls because the equipment does not comply to DSC. And yet still within the OVF I can check from the very first to the very end of the service. Okay, going further, the output data. I wanted to have a console for live troubleshooting. I have to troubleshoot the service now. I want to check it now, whether it complies with the status that it should have from the documentation. I want to have it, the output to file for reports, for in-time reports, whether the service was properly configured a month ago, what changed within the month. And to monitor, to properly monitor, you cannot watch files, at least not with the OVF PESTA checks. It's better to write to event logs and have any monitoring solution like SCOM, Zabbix, OMS, anything like that, monitor the event logs for a proper event. And then, because we're working in cross-domain environment, our company is a software company where we have a lot of domains, a lot of credentials, a lot of stuff. I didn't want to copy anything on the servers, because developers don't like when we touch their servers. They say we broke it, so we don't touch it. In a way that's not processed. So I didn't want to copy anything on the server. I didn't want to leave any trails on the server, that there was files, modules, pester, newest version of the pester, any additional things like, for example, TBHX that I would like to incorporate. So I'm connecting remotely using pers remoting, invoke command, to the server that I want to test. I'm gathering all the data, copying back to my machine, which I have all the tools needed for the pester to run. So once we had that, this was the feature list, the concept for the very first module we wanted to build. So we started to code it. To recap, we have a management server that is running all the check against our service. That can be Active Directory, that can be Storage Spaces Direct Cluster, that can be anything you have the knowledge about. Then, when we get the data, we write it as a baseline and store it in a repository. And we can compare using, in our case, Git, compare it later, any other tool you want to use. The 3 is doing the checks. So once I have all the data, then I'm doing the checks against the service, whether everything's okay, and writing based on the parameters of my invocation, because I can choose whether I want to write only to console this time, because it's live troubleshooting, or I want a full audit in files and even logs. And once the data is in proper place, you can even monitor that, you can create reports, or you can just troubleshoot with your own eyes. I'd like to show you what's the code behind creating the baseline, what's the code behind the configuration and the checks itself at first. So, this is the main module, the Mateusz OVF. This is a generic module that will invoke pester tests with the parameters we pass to it. It will create event logs if required, and will run the report unit for us with a single command. So it starts with a bunch of parameter description. The most important are, if we choose to write to event log, we then define the event source. This is our definition. For example, I want within the application log to have my logs testing Active Directory stored as OVF Active Directory, so I can easily query later or filter. Then I define the ID base. This is an integer number. +1 of this number will be the information logs stating the service had the test passed with the message proper, and +2 will be the error. So it's really easy to query or to filter the event log. Then I decide whether the output folder, so if this is chosen, then the file will be generated. I can give it a name, if not a random one is created, and a tag. I will show you the tag later. But it allows me to choose which test I want to run. So at the beginning, it gets all the parameters to put them in a proper hash table, and then it just invokes clear pester. No magic here. Then, if the write to event log was chosen, it's running another function that writes to event log. How does that work? Again, parameters, parameters, parameters. If the test has passed, I'm creating a message based on the fixtures from the pester. So the blocks that you create, the describe, the context, and the it, will be in the message in the event log. So the more descriptive pester test you create, the more descriptive event log messages you will have. And the 3 is the status of the test. Again, with the failed, there's additional information. It will be describe, context, the name of the test, whether it passed, and what was the failure message. So right within the event log, you will not only see that the service, the test was failed, but also why. This is also from the past. And report unit is just a simple wrapper for public report exe. You can If you don't trust my exe file in here, you can point it to your download with the hash verify. This is just to simplify the deployment in our environment, so I won't have to copy and download the report.exe file every time. This is the first one. So now, how the diagnostic module looks like. It has a basic layout, like most of the modules, private public functions. Diagnostics folder contain all the tests for the services right now I have incorporated, and the configuration. The configuration is for the files. So in here, this is a simple hash table, a contract. I'm building the module, I'm giving to you. You won't have to scope through all the files. You won't have to scope through all the diagnostic tests to know which tags you can use for my tests, which tags you can, how do you connect to the remote machine. As for now, only credentials and remote session are built in, but later on I plan to add GIA for that, so that you will have the possibility to connect with even more secure options to your tests. And looking at this simple manifest, you see that the operational test for the Active Directory will require only credentials and the configuration. What is the configuration then? My environment will be slightly different than yours environment, and I don't want to have that within the public repo. So once I create the baseline, I put it in my own repo, in my closed source Git repo, and once invoking the generic tests, I'm just pointing, there's the configuration for the Active Directory for my domain, use that to perform the tests. Because it is created through the baseline, you won't have any issues with the objects. It will be created for you and by you. You're going to see that in a moment. Then this is ripped off from DSC. So any configuration that is for the service itself is called non-node data. If there are any servers that should be included, like for example the HCP servers within the domain, you can query the Active Directory domain to check what are the DHCP servers running within your authorized domain, and that will be stored in non-node data. But the configuration for the DHCP server, you can have different sites, different scopes, different reservations, and that will be put into all nodes with the node name, so with the server name for the configuration that you're going to show in a moment. Now we're going for the diagnostics. So how does the tests look like? There's the comprehensive and simple folder, which also follows the OVF guideline from the Microsoft repository. And then we go for the simple configuration and operational tests. What's the difference? The operational test will tell you within seconds whether your service is running properly, and the configuration tests will compare the config you have, the baseline config you have, against your live environment. That's what, then you can choose whether you want to run the full tests every hour or just the operational tests. Whether after a maintenance, for example, a reboot of the storage spaces cluster node. So I'm putting one node into a reboot because I need to replace the NVMe card, and I want to check after the reboot whether the service, the full service with, whether there are no storage jobs running, no live migrations, no storage migrations. So for example, I could put another node into the maintenance, not waiting for the validation to finish. Then I'm passing the configuration as a parameter, the credentials, because they will be within these tests needed for querying the Active Directory service. And then it's just simple object should be object. Nothing complicated. Okay, so how do we get the baseline in the first place? So there's the master function, which at the beginning, as a contract says, I will be querying Active Directory for this kind of parameters. And then using native commandlets, using native methods, it just populates the properties. It uses some quirks because when you do invoke command into the system, it usually the data gets back with PS session name and additional attributes I don't want to have within my object. So sometimes I have to strip them with the remote session and then just get back the plain object After the properties are populated, I'm just returning the full object. So the new baseline will just require the computer name. This is one single domain controller within your forest that you want to query. It will get all the information from there. The credentials, because it will ask some additional parameters from the Active Directory, so it's not only the discovery phase, and also the folder where you should put the configuration. And because I'm using the same, I'm building the folder structure, the node data, all nodes, so you don't have to build it yourself. And then I'm using the commands I'm using for getting all. Hold on, here it is. So I'm using my commandlets for building the baseline as well. So I'm using them not only for testing, but for building a baseline so that the object is consistent. Okay, so I've got my tests, I've got my baseline generated for Active Directory, I have my functions for any other. So how does I start the diagnostics? Again, this is the list of all the parameters that both of the modules, the functions from both modules, will accept. That includes the event ID base I showed you before, the service name. Currently only these are incorporated, not enough time to the full service. Where should be the data put, the files, whether I want to prefix the file with some domain, for example, name, because I will be testing different domains, so it would be wise to distinguish that. All the parameters that are for the tester, the tag, so I can choose whether I want to test, for example, storage spaces direct cluster only for network properties. I don't want to run the full scan for storage, for CPU, for RDMA configuration, just one single element that's being of interest for me. Also, for example, I've rebooted only one node in a 6-node cluster, and I do the operational tests for the cluster, and then run the full configuration compare against a single node, because I changed only a single node. And then just a placeholder right now for the GIA. If you've got the GIA implemented already, you can use the configuration name in here, and it will use the GIA to connect to the machine. Then building the parameters, nothing important here. Then, because I have already some tests in here, it will, if you provide the service name, it will query its internal database for the service and use the test itself. For example, you want to modify the tests and don't want to put that into public repo. You can copy my tests, put it into your folder, and instead of providing the service name, you provide the service configuration path for the folder, and it will use your tests instead of my tests. The only drawback is it will have to use the same object and the same properties, which you can easily see in the manifest of the baseline configuration. Then it will just write log. Write log is a function of our ppush tools, so the base module we're using. If you're interested more, it's very talkative. We like our functions to be talkative. They're putting all the information in the console, using write host, so it's not populating the output. And it's also easily integrated into CI tooling, like TeamCity, Jenkins, or Apvea. So any messages I want to put in here will also end up in a console of the TeamCity or Apvea. Then I'm getting the configuration data also from the ppush tools. Right now I'm storing the configuration data in JSON. I can also store it in PSD file. With this commandlet, you don't care. You just put it in the PSD or JSON, it will distinguish what file it is and create a proper output. We're looking into incorporating that also as a SQL table, so we can move your data into SQL and then just write a wrapper, and inside your functions you change nothing. And once all the object is generated, all the parameters are defined, it started to run for the test. So it scopes for the configuration and says, okay, you want to run the comprehensive operational tests on all nodes, then distinguish if you decided the parameter node is selected and checks only for the single node. If not, it will query the whole cluster for all the nodes that are up and will test it. and using the operational tag will fire up this file. So if you want the configuration, these tests won't be fired up. Once it's done, it generates files for every test, for every node it did run through, just a copy for the XML. Okay, enough of the internals. I've talked too much already. So let's see within the demo how to create a baseline within seconds, how to perform operational checks, how to compare the configuration, how does the reporting with the report unit looks like, what can we see and do with the event logs, and then how does it run in our production environment using the scheduled tasks, because everything is built as a module, as a functions. I'm just pushing the module using TeamCity in our deployment to my management server, and from there I'm building a scheduled task that will query the function, it will run the function, and all the information will be in place. Because those checks are performed on our production environment, I've pre-recorded everything, so to be sure whether the VPN or Wi-Fi won't go nuts on me, and also not to disturb within the configuration for my guys, because, for example, if they are patching right now, I think, one of the nodes, we would get different results than I would expect. So all the demos are pre-recorded. Okay, what do you need to do to create a baseline? First, because this is run from my machine, so I'm importing the modules from my location. Then I'm using the stored credentials, because I'm not using my own, to access the environment. Just some simple folder configuration where the data should be stored. Right now, I have configuration for 3 services and malicious Active Directory configuration. And then I'm just invoking, create me a new baseline for my domain, for my Active Directory domain. There are only 3 parameters that should be passed through, and that is all that is required to get you Active Directory baseline. The same for the DHCP and for the baseline. So quick run through, how does it look like? So again, I'm importing all the modules. I'm getting my credentials in place, initializing the variables for the tests. As you can see, this is empty, no shenanigans behind that. And I'm invoking the baseline. Done. Let's go for the DHCP. Now we can see the talkativeness of our write log. It gets the date, the computer it was run from, the user that was running the configuration, the function, which function from which file it was run, and which line. If you need to debug something or troubleshoot in the production, and your tests were running in a release pipeline, so within the TeamCity, you won't have to go very deep to get where the error was. This is why we like our functions to be talkative. And now I'm running the configuration, the baseline for our storage spaces cluster. This takes a while, so I'm gonna cut it. The video is edited. Right now, getting the configuration for one node is like 90 seconds. Within 90 seconds, I get the full configuration of one node. Our 6-node cluster takes nearly 10 minutes to get all the data. So how does the data look like when you already have the baseline? Yep. Okay, so this is not in here, this is in here. So this is my configuration folder where I copied all the configuration for this demo. As you can see, I have every service in its folder. I have the all nodes and no node. The Active Directory is just a simple JSON stating what level of my domain is, what are my controllers, where are the FSMR roles, what is the password policy, who should be, this is by purpose, who should be in the high groups configuration, what are the sites and what are the trusts for my within my domain. It's all being generated automatically. As for the DHCP, this file is rather simple. We have two sites with DHCP servers, and then we go for the configuration where you have a few lines. Yeah, a few lines. All the scopes, we've got a lot of scopes. We've got lots of VLANs. All the scopes in here with all the options, so any click admin gonna change any scope within your organization. You're gonna know that once the test's gonna run. You don't have to check 30, 40, 50 scopes and all the options inside. To run the DHCP tests, how much do you think it takes to query this DHCP server to compare the configuration with the JSON? Any shoot, any time, any seconds, any minutes, any hours?
50 seconds.
Okay, it takes 80 seconds. Most of that is because the commandlets are run within the invoke, and that takes a little bit of time, a little bit of overhead to query all the scopes and put that into hash table and pass it back. So 80 seconds to verify the DHCP server. That's not bad, I think. Okie dokie, we've got the baseline done, the configuration done. What should I do? Go to demo 2. So within this demo, I'm going to show you how the checks are being performed, because the only thing you've just seen was creating the baseline. That's not good enough. So again, importing the credentials, folders, and this is how you invoke your first test. The output will be put only on console right now. I want to test this service configuration. I want to test Active Directory. I want to see the results, and here are the credentials. That's it. If you go a little bit further line, you can create a file for each of those tests and put them in here, or you can write to event log. You can show for the console, and you can write to the event log. I hashed the parameters in here, but you could get only one node and only operational and only comprehensive tests. So it will choose and pick what test you would like to run. Then I'm going to prepare the reports based on the XML files using the report unit and show you how the index looks like, and then we're going to dive deep inside. So let's start the checks. It's a little bit longer, 3 minutes. So yes, I'm again importing the modules, getting the credentials, variables, nothing new. And then we're going to query the Active Directory. What's your stat? As you can see, I've added the folders in here because I wanted to have the reports. The pester tests run in the background, the write logging of the function. It took 2 seconds to run the operational tests. It was 27 tests. Now we go for the DHCP. This is also edited because I don't want to bore you with looking at the progress bar. So within here it says, okay, I'm going to use these credentials to connect to that machine, which is very important in our release pipeline because when it's running as a part of the TeamCity build, because we can validate the infrastructure before we build a new VM. So our release build says, build me a new VM. We'll test the cluster whether it's suitable for a new VM. If it's in operational mode that is not suitable for that, for example, in maintenance mode, it will not build the VM. And because it's running behind the scenes, if anything goes wrong, I want to show the output from the TeamCity and see exactly which line, which file failed. I'm not into writing any unit tests. If you want to know why, just come tomorrow to our release pipeline. You're going to see how many modules we have already. So I want to verify afterwards everything's okay. And this is testing. As you can see, 10 seconds for operational tests. It was like 80 seconds for the configuration tests. And now the cluster. What it does in here, it first tests the cluster role, so all the service, all the resources for the cluster, like name, cloud witness, etc., which should be in proper shape, whether there are any storage rebuild happening right now. One of those failed tests was NetFlow configuration. Then it checks node by node for all the parameters. Because you can have different nodes than mine, you will probably have different nodes than Mateusz. It's generic. It will query first the server, distinguish what kind of adapters you have, whether you have teaming or not, whether you have RDMA adapters or not, and it will build the object respectively. So in our case, we've got 4 10G NICs that are on board. They're used for teaming for VMs. We've got 2 Mellanox CX3 Pro for the RDMA. And based on the teaming, we've got virtual NICs where we have the IP configuration. And it just built that automatically. When I run it on a Hyper-V server, a standalone server, which has a totally different configuration of NICs, CPUs, and drives, it generates me the object I require, and the tests will run flawlessly anyway. Okay, so you saw all the tests. What else? How does the files, how does the reports look like then? Okay, got it here. So, as one can assume, my Active Directory is in perfect shape. Should be at least. The name of the tests are the name of the diagnostic files from within the module. If I click into, I get all the fixtures and posters from the tester that I can check whether my site's configuration is proper, whether the domain configuration is proper, etc., etc. My CISO would kill me. This is the HCP. It tests 144 operational tests because it was running only operational tests for the reservation. I had a tag saying, I want only reservation tests. Don't get me the full output. And the S2, as you can see, some failures in here. This indicates already that we have our server in not that good shape. And I can show you one thing. Okay, it will be on the OMS. Anyway, if I'll click into the tests, I will see exactly what failed on which node, which test, and what should be the default output for the test. So this is user-friendly. You don't need to learn PowerShell. You don't need to know PowerShell if that is built for your support, stating whether my computer is in a perfect shape. With this kind of output, I think they can figure it out, that it's missing some updates or applications, or it's not being properly added to Active Directory domain. Imagination is your only constraint right now. Okay, let's go. Thank you. Okay, the demo 3 is a really quick one. I've altered a little bit the configuration of my documented Active Directory. So I haven't changed anything in a live environment. I've just switched a few bits in there in the documentation, for example, raising the Active Directory level domain. What that means is that you can use those tests to perform the testing before you introduce the change within your infrastructure. So, for example, you're planning to upgrade your forest level. Just alter the documentation, run the tests, verify everything's not okay, upgrade the domain, run the tests again, and then you've got the report for your change management system. It was this, it is this. It's as simple as that. You don't have to write an essay in Jira stating what's wrong, what's not. And again, all the same parameters, the output, and the demo. Again, import, import, import. And within seconds, I'm going to see on the console something's wrong. It's going to be red, and it shouldn't be because my domain should be in perfect shape, right? Well, not in this case, by purpose. So I'm just invoking the tests, and oh shit, a lot of red. It wasn't user-friendly, and scoping through ISE to see the errors is not a user-friendly way of saying, okay, something's wrong, something not wrong. That is why the pester output, the unit XML file, and then the report unit comes in handy. So I get the report, it's done, and this is how the file looks like. I'm going to show you in a zoom in a second. Okay, so you see, because this is something I need to work on, because I was running only configurational tests, but it found the operational test, it did perform the XML file, which is empty, there are no tests inside. This is to fix in MVP2. But the configuration tests were run, and I can dive deep that the verify default password policy for the domain is not what it should be. It should be 4, but was 8. So I expected 4 because this was in the configuration, and it found out in the live system that it was 8. So the fact it was not as it should be in the configuration, and now you have to decide whether someone changed the environment or the documentation is wrong because someone failed to update the documentation once the change was performed. This also acts as a second check. We had that, you're going to see that in OMS. We did a maintenance reboot for a server, and we forgot one action to perform, which was caught up by OMS and fixed the issue for us. Okay, what's next? Go to Demo 4. Demo 4 is about event logs. So you're going to see that these event logs will run on my workstation. I'm just filtering right now for S2D. 1001, so I'm going to get all the information logs for checking storage spaces, and you can see the description, the fixture, and the posture are just exactly the same as they were in the pester tests, in the describe logs. Now I'm going to show you the errors. So we've got full information, what should be and what it is. Yay, that's it. Okay. Now, we've got scheduled tasks running in our environment. And running a scheduled task on a server is a simple thing, but we've altered that a little bit. So every hour, I have this script file being run by a scheduled tasks. What does it do? At first, it creates the configuration and the log folder. So all the write logs you saw on the console, all the write logs messages that should be write to the TeamCity will be write to a log file on the disk. So I will exactly see, in case of failure, what go wrong where. Again, because this is a production server, those modules are deployed in a proper place, so I'm not importing from some C repos, Czerniawski folder. I'm getting the credentials for the tests, so the scheduled task does not have my credentials. It is allowed to pick into this XML file for the credentials. Tomek did a nice thing. We are building the credentials on the fly. So we pass that as an argument to a TeamCity build. While TeamCity creates the scheduled tasks for us, it also creates the XML file on the disk and grants the scheduled task, because it's run on the same user, it grants the scheduled task the ability to use these credentials. So in fact, I can use some random password, alter the Active Directory account with the random password once the build is running and building the scheduled tasks. So even an admin won't know the password and won't be able to use it. Of course, he will be used to log in as the service, but they can be logged into CM system. Then I'm building the full parameter list for that, saying, okay, I'm testing Active Directory, the event base is 10,010, I want only operational logs, no configuration, and put it in here. And all the information built from the write log will be put into a file. And I'm invoking the Active Directory tests, the HCP tests, and S2D tests. Generate reports runs weekly, grabs all the XML files from the folders and creates HTML file. It will be updated after a week if new tests are in the folder, so no lost, no data lost. How does the log look like? As you saw before on the running, it's just the same information saying, I will be reading the configuration from this file, I will be using this and that user to connect to the environment. So all information an admin will need in troubleshooting. And how does the file look like? So I've got all my tests, because they are only operational, and as I said, I'm still working for the file generation. I see that my environment is in a perfect shape right now. These tests are run every hour, and if I want to get that in case of a failure, I've got OMS watching for me. So the information is written in event logs. I won't be checking the event log every so or never. So I've got OMS looking the agent installed on the management server. That's another benefit. I have one management server querying my 300 server domain environment. I don't have to install the agent on 300 servers. I don't have to install and monitor 300 servers with OMS. It would be great, but it costs money. So I'm adding an agent only on my single management server, which queries all the environment that is required, stores information in its logs. OMS catches that, and in case of a threshold violation, so for example, for the DHCP server, if there are 3 or more errors within 15 minutes, just put me a message on JSON, just put me a message using JSON on Teams. So I will be notified on my phone something's wrong, and I'll get all the information because OMS sees that. So I will get all the information that are in the described log. So, for example, if anything's broken with the workstation's deployment, the support team will get on its team channel all the information that this and that workstation missing, for example, BitLocker configuration, because the WDS went wild for that machine, for whatever reason. They won't have to check that manually. It will be done by them automatically. And that cuts off one of our greatest flaws. That means failure. People fail. Machine fail as well. So why not double check that? Okay, back to presentation. It will be just last slice, promise. Okay, just to recap. The composition of the OVF. The first module, the OVF, is responsible for invoking the pester tests, writing to event log, and invoking the report unit. The diagnostics hold right now hold the roles of documentation, of the checks itself, allows me to tag and node select which tests I want to run, and invokes into remote systems. The plan is to add also the SSH compatibility, so I can test, because I will be able to log into Linux machine, gather the object using Bash, using Python, whatever I like, because the object will be passed back to my management station when I'm in my most knowledgeable environment. I know Windows and I know PowerShell, so with the object I can do whatever I want. I can perform any test I want. So this is the composition. Where to get it? It's available on our GitHub. It's based on the ppush tools, so that is something you would have to get as well. That is the framework for the write log, for accessing any additional features. If you're interested, just come to our release pipeline tomorrow. You're going to find out more. And then both the modules. Because I'm planning to split the diagnostic module into different areas, because not everyone who has storage spaces direct have Active Directory. Wrong. The opposite. Not everyone having Active Directory have the storage spaces direct. So this will be split into areas of interest. The Active Directory, DHCP, GPO tests, labs configuration, if you have that, will be in one area. Hyper-V in the second area. Our closed source, like WDS or employee maintenance flow, will be in closed source projects. So after that is split, it's going to be published to PS Gallery. Then you can install that with install module. As I said, I'm planning to add the GIA, and it would be nice to have some security best practice checks for your service that would query, for example, Active Directory, whether you don't have any over-delegated EOEs in your Active Directory, whether all the GPOs you're using right now are being linked somewhere and not being unauthored ones. So those checks will have the security tag for a better distinguish, and I think quality and security departments will will love that. Okay. With these modules, as a summary, with these modules, I'm able to perform a quick documentation of my service, whether it changes or not, whether I add additional node for the cluster or not. I'm able to perform the checks interactively as a troubleshooting and as an audit trail putting into files. I'm also able to monitor the outcome using SCOM, Zabbix, in our case, OMS, very easily, and notify the proper teams in case of failure. Because it's using XUnit files, it's release pipeline compatible. It's compatible with any CI tooling out there that's able to consume XML files, like Jenkins, TeamCity up there. And it's ready for create scheduled task reports, so I don't have to click on that every week, every day. If my manager decides he wants to see the Active Directory output every hour, I'm going to flood it with emails. It will flood it with emails. I won't have to do anything else. Okay, do you guys have any questions? Okay, so no time for questions. I'm gladly answer all the questions in here. Just have your 15 minutes and prepare for the last session and then for the zoo. Thank you.